In this video, we will be solving some problems of chemical kinetics which was asked in JEE. Now the first question says, if the formation of compound B, that is they have given a reaction A gives B. Now if the formation of compound B follows first order kinetics after 70 minutes, the concentration of A was found to be half of its initial concentration. So, if the concentration of A is found to be half of its initial concentration, then the time which is given, that is the 70 minutes, is nothing but the half-life of that particular reaction. So, essentially, half-life of the reaction is given to us. It is 70 minutes. Now, they have also given that it is the first order reaction and they are asking the rate constant. So, this is a simple question. We already derived the formula for the half-life of first order reaction, which is nothing but half-life is equal to 0.693 divided by rate constant. It doesn't depend upon the initial concentration of the reactant. So now it is simple. Now K is equal to 0.693 divided by half-life. So it is nothing but 0.693 divided by 70 times 60 because they have asked in terms of second inverse. Now on calculating, we get the answer to be 165 into 10 power minus 6. So our x value becomes 165. This is the answer. Let us move on to the next question. So in this question, we are adding a catalyst A that reduces the activation energy of a particular reaction by 10 kilojoule per mole at temperature 300 Kelvin. So here the change in the activation energy and the temperature is given. Now they are asking the ratio of rate constants. So we have already derived an equation in our second video where we discussed about the effect of a catalyst in a particular reaction. That is, we just substituted the given credentials in the Van Hoff's equation and we got a reduced equation to be K final divided by K initial is equal to E times E power the change in activation energy divided by RT. So this was the equation we derived where K final was the value of rate constant in presence of catalyst and Ki was the value of rate constant in absence of the catalyst. So now using this equation, this problem becomes simple. Now the K final was, now they are asking this ratio K final divided by Ki. So Kf by Ki is equal to E power, the change in activation energy is nothing but 10 kilojoules, so 10 into 1000 divided by R, they have given the value to be 8.31 and into temperature is 300. So on simplifying this, we get e power 4.01 approximately. Now since this was an integer type question, they have asked the value of x. So exact value of x is 4.01. So rounding it off, we get the value of x to be 4. So this is the answer. So this is our next question. Now the equation is given to be gamma 1a plus gamma 2b gives gamma 3c plus gamma 4d. This is a chemical reaction. Now they have also given concentration of C changes from 10 to 20 in 10 seconds. Now we can find dC by dt from here. Now this data also have been given that rate of appearance of D is 1.5 times the rate of disappearance of B, which in turn is twice the rate of disappearance of A. That means the rate of disappearance of B is twice the rate of disappearance of A. Now the next data which is given is nothing but the rate of appearance of D, which is 9 millimole Dm power minus 3 second inverse. Now they are asking the rate of a particular reaction. Now this is a good question because this involves a lot of manipulations. Now, by writing the given data from the question, they have given the rate of appearance of D is 1.5 times date, the rate of disappearance of B. So that is why I have written here. And by rearranging, uh, by writing the term 1.5 as 3 by 2 and bringing 3 to the other side, so that we write it in the form of the rate law equation, we get this equation 1 by 3 times dd by dt is equal to minus 1 by 2 dv by dt. Now similarly the second data which is given to us is rate of disappearance of B is twice the rate of disappearance of A. That's what I have written it on the right hand side. Now similarly rearranging this 2 on the other side, we get minus half dv by dt is equal to minus dA by dt. Now combining the equation 1 and 2, we get equation number 3, which is because half dv by dt is the same in both the equations, so we can equate it. So we are getting this type of equation. So why we are doing this is basically we have to get the coefficient value, which is gamma 1, gamma 2, gamma 3, gamma 4, because we know the fundamental type of the rate equation. Now we can find dc by dt because the data is given in the question that the concentration changes from 10 to 20 in 10 seconds. So it is nothing but the change in concentration, which is 20 minus 10 divided by time, which is 10. That is equal to 1 millimole dm power minus 3 second inverse. Now dd by dt value is also given in the question, which is 9. So automatically we can come to this relation, which is dc by dt is equal to 1 by 9 times dd by dt, because 1 by 9 into 9 is equal to 1, which we have already found. Now similarly, by rearranging the terms, uh, we are splitting this 9 into 1 by 3 into 1 by 3. So we bring 1 by 3 to the left hand side. So the final equation becomes like the equation number 4, which I have written here. 1 by 3 times dc by dt is equal to 1 by 3 times dd by dt. Why I am doing this type of manipulation is we already know 1 by 3 times dd by dt from the relation in equation number 3, as given here. I am circling it. So that is why we are finding dc by dt relation. So combining equation number 4 and the previous equation number 3, we get our final equation to be minus dA by dt is equal to minus half dB by dt is equal to 1 by 1 by 3 dc by dt is equal to 1 by 3 dd by dt. So from here we can compare the coefficients because we know the general equation. I am writing it down here. Minus 1 by a dA by dt is equal to minus 1 by b dB by dt is equal to 1 by c dc by dt is equal to 1 by d dd by dt. So this was the general rate equation where A, B, C and D were the stoichiometric coefficients. So comparing this, uh, below dA by dt we have 1. So the coefficient of capital A becomes 1, and here we have 2, so it becomes 2, and here we have 1 by 3 and 3 respectively. So our equation becomes A plus 2B gives 1 by 3C plus 3D. Now multiplying by 3 the whole equation, we get 3a plus 6b gives c plus 9d. So therefore we got the gamma 1, gamma 2, gamma 3, gamma 4 as integers. So gamma 1 is 3, gamma 2 is 6, gamma 3 is 1 and gamma 4 is 9. So again we are writing the rate equation for this equation, that is after multiplying by 3. So again writing this, finally we get the rate equation to be minus 1 by 3 times dA by dt is equal to minus 1 by 6. We are actually writing the rate equation for this particular reaction. 3a plus b gives 3a plus 6b gives c plus 9d. that is after multiplying by 3. For this equation, the rate equation is this. So the rate of this particular reaction is nothing but equal to minus 1 by 3 times dA by dt. That is equal to minus 1 by 6 times dV by dt. That is equal to dC by dt equal to 1 by 9 dd by dt. So all these values are the same, and we already know the value of dC by dt. So the rate of the reaction is nothing but equal to dC by dt, which is nothing but 1 millimole dm power minus 3 second inverse. So the answer is essentially this. This the answer. This is an integer type question, so the answer is 1 here. Let us come to the next question. Now this question was asked in JEE Advanced 2018. Let us go to the question. So for a first order reaction, they have given A gives 2B plus C at constant volume and 300 Kelvin. So the temperature is given to be 300 Kelvin. And the total pressure at time t is equal to 0 and at time t are P0 and P1 respectively. So P0 is the initial pressure and the P1 is the final pressure at time t. Now initially only A is present with concentration A0. So initial concentration is A0 and T1 by 3 is the time required for the partial pressure of A to reach 1/3 of its initial value. So T1 by 3 is nothing but the partial pressure when the pressure is 1/3 of its initial value. Now the correct option is or R. So this is a multiple correct option question. Now option A is natural logarithm of 3p0 minus p1 versus time graph is given. The option B is t1 by 3 versus a0. Option C is natural logarithm of p0 minus p1 versus time. The option D is rate constant versus initial concentration a0. Now let us see the solution of this question. So the given equation is A gives 2B plus C. Now here temperature is given to be 300 Kelvin. Yeah. Now at time t is equal to 0, pressure is given to be P0, and at time t is equal to T1 by 3, that means they have given the pressure is reduced to 1/3 of its initial value. That means P0 becomes P0 by 3. So in order to become P0 by 3, so this was 0 and 0 initially. So in order for the pressure to become P0 by 3, 2 P0 by 3 must have got subtracted from P0. So if 2 P0 by 3 is reduced from A, that much value adds stoichiometrically to B and C. That means 2 times 2 P0 by 3 would be the partial pressure of B, and 2 P0 by 3 will be the partial pressure of C. So this becomes P0 by 3 then. Now at time t is equal to t, let us assume. So as usually from the initial pressure, let us assume x pressure reduces. So here 2x pressure adds and here x pressure adds for the C value. Now the total pressure at time t is equal to t is nothing but add P0 minus x, 2x and an x here. So if we add all these three, we get P0 plus 2x. Now let us assume the total pressure is some Pt. Now how can we write x in terms of Pt and P0? X is equal to Pt minus P0 whole divided by 2. Let us assume this as equation 1. Now what we can find, now we know the first order equation. First order equation is nothing but k times T is equal to natural logarithm of initial pressure Pi divided by final pressure Pf. This is the general equation. Now applying for this question, Kt becomes logarithm of pressure initial was P naught and the pressure final is P naught minus x, because we assumed x to be subtracted at time t is equal to t. That is why t is here. Now we have already found the value of x from the first equation. X was pt minus p naught divided by 2, because we have to relate pt with x somehow. That's why we derived the value of x first. Now let us substitute this value of x here. Then we get kt is equal to ln p naught divided by p naught minus pt minus p naught divided by 2. Then we get, by simplifying, we get ln 2 p naught divided by 2 p naught minus pt plus p naught. So therefore we get kt is equal to ln 2 p naught by 3 p naught minus pt. Using the property of logarithm, we can write it as kt is equal to ln 2 p naught minus log 3 p naught minus pt. So we have come to this step. Now at this point we can notice that in question an option was there considering logarithm of 3 p naught minus p1 versus time. So we have got something in the form of a straight line equation. Now let us rearrange the terms for more conceptual clarity. So now ln 3 p naught minus pt is equal to minus kt plus ln 2 p naught. Now this is in the form of y is equal to mx plus c, where m is equal to minus k. So k is a positive value always because it is rate constant. So the slope is negative and we get the graph to be a straight line. So obviously our first option is correct here. So option A is correct. Option A is correct because the slope is negative and the line is a straight line. So obviously option number C becomes false because it is ln p naught minus p1. Here we have 3 p naught minus p1. Yeah. So now let us check option number B then. They are asking T 1 by 3 versus A naught. So now T 1 by 3 versus the option was, I think, T 1 by 3 versus A naught here. So here what we can do here, T 1 by 3. Okay, so the general first order equation is kt is equal to ln pf by pi. Now for this question it becomes when pressure sorry, this is pi and this is pf. So when pf is equal to p naught by 3, that is at the instant when t is equal to t1 by 3. So the equation becomes kt1 by 3 is equal to ln p naught divided by p naught by 3. So therefore we get t1 by 3 is equal to ln 3 divided by k. Yeah. So this value we get. So from here we can notice that ln 3 is also a constant and k is the rate constant, which is always a constant. So the total value becomes constant. That means t1 by 3 is always a constant here. So that means in our options. Option B is wrong. It is incorrect because they have given a straight line. We have got the answer that T1 by 3 is always a constant. It has to be a horizontal line versus the initial concentration. And option number D is obviously correct because rate constant is always a constant irrespective of what the initial concentration is. So this we already know. So the correct answer is option A and option D. Now this is our next question. This was asked in JEE Advanced 2017. Now the question says, in a bimolecular reaction, the steric factor P was experimentally determined to be 4.5. The correct options are, so option A, the activation energy of the reaction is unaffected by the value of steric factor. It is obviously correct because the activation energy, it does not depend upon the value of steric factor. Now because the collision theory equation is that rate is equal to Pz AB into, if A and B are reactants, it is ZAB into e power minus EA by RT. So here P is separate and EA is separate. Otherwise also they are independent of each other. So it does not depend upon the steric factor. So option A is correct. Option B is that experimentally determined value of frequency factor is higher than that which is predicted by the Arrhenius equation. Yes, this is correct. Experimentally determined value of frequency factor is higher because the Arrhenius equation predicted that the steric factor P lies between 0 and 1. So here obviously in the question it is given that the value of P is 4.5. So it is higher than that predicted by the Arrhenius equation. Now, option number C is that since P is equal to 4.5, the reaction will not proceed under an effective catalyst is used. Now this option is wrong because as the value of P increases, rate also increases. Now the value of P is 4.5, which is sufficiently large when compared to the P value which lies between 0 and 1. So if the P value is very small, then only the catalyst is required to carry out the reaction at a measurable rate. So since P is 4.5 here, so the reaction can proceed without an effective catalyst too. So option C is false. Now the option number D is the value of frequency factor predicted by the Arrhenius equation is higher than that determined. This is obviously false because option number B is correct. So our correct options are option A and option B. Thank you.